Alright, we're going to talk a little bit more about heat in these notes. But first, let's start with some review. Write this question in your composition book and answer it. Pause the video while you do. What is the difference between thermal energy, temperature, and heat? As we talked about before, thermal energy is the energy due to moving or vibrating particles. It is the sum of the kinetic energies of the particles. All phases of matter contain thermal energy. Temperature is a measure of the average kinetic energy of the particles in a substance. Temperature doesn't change during a phase change, but thermal energy does. So for thermal energy, we're adding up the kinetic energies, but for temperature, we're averaging the kinetic energies. So now for heat. Heat would be the transfer of thermal energy, so that's the movement of thermal energy. Always from an object with a higher temperature to an object with a lower temperature. The examples we've talked about are conduction, convection, and radiation, and it is measured in joules. Now let's talk about how to calculate heat. The heat equation is Q equals mc delta T. Q stands for heat and is measured in kilojoules. M is for mass, measured in kilograms. C is for specific heat, measured in kilojoules per kilogram Kelvin. And delta T is the change in temperature, which would be T final minus T initial, and that will always be in Kelvin. Well, what in the world is specific heat, you might wonder? Well, specific heat is the amount of thermal energy required to change the temperature of 1 kilogram of a substance by 1 Kelvin. So it tells me how easy or how difficult it's going to be to raise the temperature of something. The higher the specific heat, the harder it is to change the temperature. So let's do an example using the heat equation. Write this question in your composition book and then we'll work through it together. Pause the video while you do. Start by writing down the given information. The mass is 2.4 kilograms. The specific heat is 0.899. The change in temperature would be 293 Kelvin minus 273 Kelvin, which gives us 20 Kelvin. Next, write down your formula, which is the heat equation, Q equals mc delta T. Now plug the values in that we know. Put all of that into your handy dandy calculator and you get an answer of 43 kilojoules. Don't forget to box your answer.